What up, everybody? Welcome to Coffee Hour. My name is Paul Abernathy. Hopefully, you're getting your day started here. Either you're headed to the job, you're at the job, you're just getting ready for your safety meeting. Maybe you've already had your safety meeting. Maybe you're just rolling out of bed out in California. Maybe you are not even out of bed yet. Thanks for joining us and for being here. We know there's a lot of things you can do, and to take the time to join us, we very much appreciate it. Hopefully, you get something out of Coffee Hour. I enjoy getting up and doing it. And even as hectic as it is around the household here, as y'all know, it's still enjoy getting up and doing the show and being able to connect with folks. And it's like always, I live vicariously through you folks. So do me a favor in the chat. Let me know who you are, where you're from, what you got going on. You're testing, you're not testing. You've achieved something recently you want to share with everybody. Anything you want, go ahead and share it in the chat, and we will get it up on the screen, and I will do my shout outs and let you know, everybody to share the goodness. A couple things. We just put out a new podcast today. Go check it out. It's on the Master the NEC podcast, but I also think it's on the Let's Ask Paul podcast. We put out a new episode that talks about the failure to achieve. And it is something that has a lot of people have an issue with is that you don't think you're not achieving what you want to achieve in the amount of time. You fail an exam or you fail a contractor's exam or something like that, and you get down in the dumps and you just failure to achieve what you felt you should be achieving or have achieved or whatnot, or it's not uncommon to feel that way. So I encourage you to go listen to that podcast. It'll lift you up a little bit and kind of maybe help your day a little bit. So that's over on Mastering the NEC podcast. That's our main podcast, Master the NEC. It's also available from our mobile app, which is free, by the way. All you got to do is go over to our website, Paul Abernathy. Go right here to fasttracksystem.com, and that's where you would download the mobile app. It's free. Doesn't cost you anything. We're not going to push stuff down your throat. We're not going to try to sell you stuff. It's just a nice mobile app. And it also has a neat chat feature that if you register in the app, you have to register in the app. If you do that, you can chat. And I have been posting some code questions over there. And don't get a lot of activity on that chat feature. So if you got our mobile app, make sure you go to the very top and register. If you're not sure what that is, I'll show you. So if you got our mobile app and you were to go to the mobile app, and there it is right there, kind of hard to see, is right up here at the top right here. You have to register. Okay, I know that's hard to see. You have to register in order to be able to post comments. You can access all the other stuff on there, the blogs, the everything else, the Coffee Hour. You can actually watch Coffee Hour directly from your phone with one click. And you can listen to all the podcasts from there as well. So there, and I'm sorry about that reflection, but there you see there's three of them there. One is the Master the NEC podcast. That's what I'm talking about today. Then you've got the Let's Ask Paul. And then, of course, you have our new one, the Bond and Ground podcast. Anyway, they're all available there. It's free. It's not costing you anything. We're not trying to get any money from you. But the feature that we're talking about is this feature. And I'm sorry about the reflection. But that's kind of, you see some code questions that I posted on here. And nobody has answered any of these code questions yet. So make sure you log in and check that out. Okay. All right, let's do some shout outs real quick. Let's get that out of the way. Today we will be going into 250.96 and 250.97, talking about it. Of course, we spent yesterday, hopefully you caught the show or you caught the replay yesterday evening. We were talking about service bonding and all that stuff that's being done on the supply side, that type of thing. All of that little extra that you have to do to assure that those connections remain intact during a fault condition. So we talked about that yesterday. If you missed the show yesterday, I encourage you to go back and watch the replay. It's available over on our YouTube channel. So make sure you go check it out. It's also probably playing on all of the platforms that we streamed it to, like Facebook and whatnot as well. So I encourage you to go check that out. Today's show is sponsored by TradeHog. So if you want to try it out and get the AI in your hand, we have TradeHog. Just go to tradehog.net, and it is pretty cool. You ask it any question you want, and sometimes you got to dig deeper into a question to get exactly fine tune it. But it's getting better and better and better. All right, let's do some shout outs real quick. Let folks know here. What's up, Frank? Good morning. Glad to have you here joining our show, as always. Marlon, thanks for joining. Glad to have you here, my friend. Paul, glad to have you here. Paul, you should have seen in your profile, your flashcards, I believe. No, it's the 25 question database. It should have it. It is supposed to rain here today in Virginia as well. So not looking forward to that. More mud. I have not cranked up the excavator in over a week, so looks like it's not going to happen for another couple days. And I still have a bunch of stumps I got to rip up before we can get a garage to even get started. So what's up, David? There's our CMECP from down in Florida. Glad to have you here, my friend. Let's see. Brandon, good morning. I'm glad you enjoyed the show. Hopefully got something out of it. Brandon, got some questions over on the mobile you might want to check out, see if you can answer those questions. Some of them are calculation questions, so give it a shot. What's up, Adam? Glad to have you here. Good morning to you. Douglas, glad to have you here, Douglas, joining us from South Carolina. What's up, Tom? Glad to have you here. Our CMECP candidate who is, I think we have I think our proctored exam is this week. So I think it is this week. So let's see here. That actually is an old announcement, but I have been was the acting executive director of the CMECP program. But I am fully decided to take that on as I reduce to other roles that we have, and I delegate more to Jeff. And at some point we'll get Jeff on here, but I am trying to delegate certain things. And one of the things about the CMECP program is that it has been very not promoted well. I'm guilty of that. I have not promoted it well. So we did a video. I did a video on it explaining it a little bit, and that type of thing. So anybody got to check that out? It is available over on our social platforms as well. So give it a check if you're interested in taking your game to the next level, testing your skills. Hell, ask Tom. He's in the middle of it right now. Ask him. He went through it quicker than anybody's ever gone through the program, even the new format. Doing quite amazing. So what's up, David? Glad to have you here. What's up, Angel? Glad to have you here, Angel, joining us over on YouTube. Glad to have you sitting with us today. Santana is in the house. Also, I'm going to shout out to all those folks that watch over on Instagram. Again, the comments over there or posts over there do not show up for the general group. So I don't know if you actually see comments on your side. I really don't know. I don't think so. I don't think it's connected. But just want to acknowledge all you folks over on Instagram. I see you and appreciate you for joining us. What's up, Rob? Good morning. Glad to have you here. Skyattle, or Skyattle, however I'm saying it right. Appreciate you. Thank you for joining. Okay. Let's see here. Tom says, thank you, Brandon. Not quite done yet, Paul. We still have a few curveballs. Yep, we still have the old proctored exam, the essay. Of course, you could start the essay now, Tom, and have it ready. The essay is basically a minimum of 500 words on any section within the National Electrical Code that you feel you have a high level of confidence in. And you can actually do, and hopefully y'all hear me okay. I got my audio thing worked out yesterday. I realized I just didn't have, there was a button on my console I didn't have turned on. That's why I couldn't hear anything. Okay. Rookie mistake. But y'all could hear it, so that was good. But you could already start your essay if you want and be ahead of the game, Tom, if you want. Again, it's a 500-word essay minimum on any topic you want within the National Electrical Code that you feel proficient enough in to be able to write it. no cheating, no chat GTP, no cut and paste. You have to write it in a way that you can convey a lesson, and we will share it when we get to that stage. We'll share it with the CMECP review selected members that are on the review board, and they will give you a thumbs up or thumbs down. Minimum of 5, and you have to get at least 3 thumbs up to make it past that final stage. For the CMECP, for those that wondered, we used to have it where you had basically you had to go in front of multiple CMECPs and ask your question, and you had to answer the question they gave you to their liking. It has nothing to do with me, to their liking. And then COVID hit, and it made it very hard to coordinate stuff. So I can't say that we're not going to go back to that, but I do realize that it takes a lot of those folks' time, and it's much easier for them to review an essay. So far, we're going to stay with that process for right now. We never know what may change. What's up, Manny? Glad to have you here. I appreciate you as well, Manny, for joining us and sharing everything and being a supporter. I do appreciate it, and you're most welcome. What's up, Nepo? Glad to have you here. Let's see here. What do we got? Charles Bailey. I see you in there, Charles. Peter. Good morning from New York. Up in the Big Apple. Good morning. What's up, Jonathan? Glad to have you here, Jonathan. Appreciate you being with us. What's up, Leroy? Thank you, Leroy. Thanks for taking time out of your day to join us. Rob, you missed yesterday as I got to sleep in. Hey, no doubt, sleeping in is a Memorial Day. But you get a chance to watch the replay, watch the replay. We talked about service bonding and all that goodness that has to do with bonding at services. It is all well, Jonathan, as we're taking it best we can. Paul says he listened to both Bond and Ground podcasts yesterday. Tell me what you think. You like the concept of the Grounding and Bonding podcast? Let us know. Okay, good, bad, or indifferent. We love to hear what you think, and if you're excited about what's going to take place, there's a lot of grounding and bonding myths and misinformation circulating out there. So the podcast is an easier way to deliver that message. So hopefully you folks out there watching, check out that podcast. It's the Bond and Ground podcast. It's also available from your mobile app as well. You can also find it on any of your social platforms, Apple Podcast, Spotify, Spreaker, Deezer, all those. Just search for the Bond and Ground podcast. That's what you'd search for. You'll see it. Good morning, John. Glad to have you here. What's up, Felix? Glad to have you here, Felix, joining us today. Edgar, glad to have you here with us this morning. What's up, AJ? Glad to have you in the house as well. Well, looky here. We've got, speaking of which, we have Joe Bellatoni, which is, you heard me do the CMECP episode yesterday. Joe is a CMECP. He is from the awarded side of the program. For those that don't know, the CMECP goes into 2 paths. There is the awarded path that we award CMECP to those who have we can validate their knowledge in the industry and their commitment to the industry and what they've given back and validate them. Joe is funny because I think Joe's been following me for literally over a decade or more on different things that we've done. So we can validate Joe. So Joe is through the awarded path, and he's part of the CMECP board. And Joe will notice he doesn't get many essays because we don't have a lot of candidates that make it to that level. They either drop out before they get there. But then we have the other path, which is you have the path of the awarded, and then you have the path of the tested. And those are the ones that actually have gone through the programs. 2 different paths, both achieve CMECP status. But we do award from time to time CMECP status to certain individuals who show. And we've had certain individuals that have denied or have turned down the CMECP because they either don't believe in it, or they don't want to support it, or they don't understand the concept behind it. Y'all are probably all familiar with somebody I love to death, Vince Delacroix. Vince Delacroix, there's no way that he is not CMECP material from the get-go, but he refused to accept the CMECP honorary, the awarded. because he does so much in the industry with IAEI, and so he just didn't feel right. Same with Brian Holland. With Brian Holland was nominated through the board of directors to be an awarded CMECP based on his years of commitments, kind of like the for IAEI. That's they call it the I can't think it was with red. God, I don't even know what they call it. Rooster, Roadrunner. That's what they call it. It's kind of the same thing for our concept, but again, it means that you'd be promoting the CMECP program. And for sometimes there's certain people, because I'm connected to the program for whatever reason, they just don't want to promote it. And that's okay too. I don't have a problem with it, because the CMECP program is about how you use it, and it's to validate your knowledge. It's got nothing to do with me. I'm just the creator of it. But anyway, to each their own, that type of thing. But we appreciate Joe and his participation. What is up, High Voltage Hands? Thanks for joining. Glad to have you here. What's up, Red Dog?
Woo, 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 woo. Big dog.
What's up, Edward? Glad to have you here in the house. Tom says his essay's already done. That's what I'm talking about. That's what I'm talking about. That's the confidence right there. Let's see here. Good morning, Adrian. Glad to have you here. John, glad to have you here, my friend. Welcome. Rob, I did, and I thought I replied. Check your junk mail, because I think I did reply, or I might have replied, unless you're talking about the personal message or you're talking about the trade hog. And we'll still got to get that set up, because we don't have a mechanism in Trade Hog yet to award somebody an entire year. So we have to build that into the mechanism, okay? Because it really wasn't time for the drawing left. I just gave that away to you. You awarded it, but we don't have a mechanism yet. So we're still trying to get that set up. What's up, Boris? Glad to have you here. What's up, Joseph? Glad to have you here. Wow, look at all the folks joining us today. Anselmo, thank you. Glad to have you here as well. All right, folks, keep them coming. Let me know who you are, where you're from. We love having you here. So if you followed yesterday and you missed yesterday, we were talking about service bonding, and we were talking about all the little extra things that you have to do to ensure that you have a good, solid bond. And there's a little extra, taking everything as piece by piece by piece, and you're only as good as the weakest component, right? Well, today we're going to shift gears from service, and now with probably what most of you are really proficient at. And again, the manufacturers of the fittings and the raceways and all those type cable connector manufacturers, they do a real good job of making sure all of their products have been evaluated for grounding and bonding applications for use with their different types of wiring method, because all of those connectors and fittings have to be listed for the type of wiring method that you're using it for. So they do their due diligence, and they do a good job with the products. So we know that they are listed for grounding and bonding, evaluated. Now with service, you can't always be sure of that, right? You know, we can't use standard lock nuts. So you get a standard lock nut that may come with a fitting, compression type of fitting, that's a threadless, and you can't assume right away that that standard lock nut's going to work with that fitting unless you see whether that fitting has been evaluated as a system with that lock nut. With it, everything comes together, and usually it has a lot to do with the amount of surface area that's going to connect to it, and there's no KOs. Okay, so all of the KOs have been removed. So there's extra things, but in a sense, you can't just take a rigid in and use a lock nut on either side when it comes to services, because you can't use standard lock nuts. So there was a lot of stuff that we had to unwrap in yesterday's episode. And so make sure you check that out if you missed it, okay? All right. What's up, Charlie? Glad to have you here. Welcome. All right, so let's go on and get into today's lesson and kind of get this ball rolling. Of course, we'll go to the code when we need to check things out. Oh, by the way, for those that are interested, all of this stuff, all of these images, graphics, and illustrations and stuff like that are available in our grounding and bonding program. So in case you didn't know, what's up, Fernando? Glad to have you here. In case you didn't know, just so you know, that This is our 2023 grounding and bonding program over here on our website. Okay, you can get it right here. It kind of gives you a curriculum overview here. You can kind of see what all is being covered, that type of thing. Kind of overview, 8 units, that type of thing. Doesn't expire. Okay, so kind of an overview talking about Article 250. It's great to have in your pocket. So that is available on our website, right, in case you're happen to be interested in the illustrations and graphics and things that we're kind of talking about today. In case you have that inkling to want to get a grounding and bonding program. Okay, all right. What's up, Titan? Glad to have you here. Hashtag win. All right. Okay, so let's get into today and talk a little bit about it. So we're going to be talking about 250.96. So what we are dealing with now are bonding of other enclosures. We're totally off of service. We left that yesterday. For those that are keeping track, that was May the 26th, Memorial Day. We talked about services, okay? It's very fitting considering it was Memorial Day. But we talked about services. And now we're talking about things on the load side. We're going to talk about the branch circuits. We're going to talk about the feeders. We're going to talk about all the fittings, metal non-current carrying parts, and all those type of things. We're going to talk about all those components. So dealing in 250.96A, general requirements for bonding other enclosures. The requirements: metal raceways, cable trays, cable armor, cable sheathing, enclosures, frames, fittings, and other metal non-current carrying parts that are to serve as equipment grounding conductors. In other words, they're all connected together to be essentially part of an equipment grounding conductor. And it's with or without whether or not we have an equipment ground of the wire type included. Okay, so we're talking about rigid or intermediate or EMT connected together with set screw connectors and connected to enclosures and all that all of this that make up potentially your equipment grounding conductor if you're using a raceway. And that's another thing that brings to mind a question that people ask. And I like to throw these things out there as we discuss. Some people said, well, Paul, if I'm using the raceway as an equipment ground, okay, and I'm doing everything I'm supposed to, I'm using listed fittings, listed connectors, they've been evaluated for part of the ground fault current path, all of that type of thing, the wire, if I put a conductor inside of it, right, if I put a conductor on the inside of it, does that conductor have to be properly sized? Because I'm using the raceway, okay? And that type of thing. So in that concept, you always, with or without the equipment ground of the wire type, you would have to size the wire type properly. In other words, you couldn't say, well, you know what? My raceway can be used as an equipment ground if it meets 251.18. The wire that I put in it, it doesn't have to be full size. It can be less. It doesn't have to meet the requirements of 250.122 based on the size of the overcurrent device. I can just make it smaller. That is not true. If you use it, if you put it in, even if it's in a wiring method that it of itself could be an equipment grounding conductor, and you put the wire type in there, you still have to size that equipment ground to the proper size based on the NEC. You don't get a break, okay? So I always like to get that out of the way because I am more than sure that over on social media, people will say otherwise. And again, you just got to cringe and look at them and go, no, that's not how it works. So you might say, well, what does it matter? Then why put it in there, right? I mean, why include a wire type equipment ground if you're not going to size it properly? I'm just saying. All right, so anyway. What is this, Paul? His comment here on the supply side bonding. Leave it to Paul to go off topic, okay, to yesterday's show. I understand everything you say about what to do. Is there, let me show it again. Is there something you shouldn't do that will make it dangerous when bonding on the service side? Yes, use standard lock nuts when you're not supposed to. What else? Oh yeah, there is other things you can do that would make it unsafe. and it's probably what you're alluding to, is that you could create parallel paths. So you could have, using the neutral in your main panel, you're bonding the ground, the neutral comes in, and you got a main bonding jumper in. It's connecting to the enclosure, right? And then you have a meter outside, and you connect it with the meter to, and you have that grounded neutral conductor running through. And you're not thinking that in the meter that the neutral is connected to the enclosure, right? Because it is. And so what happens is you end up running a supply side bonding jumper through the nipple, if you will, between the service equipment and the actual meter, let's say. And now you're creating parallel paths. You have an intended neutral path, and then you have an intended bonding jumper that you're running through it, which is probably not going to be sized the same as the neutral. And so if you lose the neutral, now you're going to have that return current back to the source traveling on that potentially undersized bonding jumper. And so that is something that people think they're doing a little extra. They think they're doing it right, and they're actually creating a hazard. So that would be one example of doing that. Now, other people will say, well, Paul, isn't that kind of the same if I have a meter outside and I have a panel inside? And we're just ignoring the fact we have to have an emergency disconnect. You're just talking issues. And they say, well, what if I have a metal raceway between the two and I'm running my neutral through and everything's bonded? Aren't I creating objectionable current and parallel paths with that application? Yes, you are. The thing about that one is the NEC tries to look the other way. The code panel tries to look the other way. The right way to do it would be to replace that nipple with a PVC. Schedule 80 if you're worried about protection, but you could get away with the Schedule 40. So that would be the right thing to do if you want to remove the objectionable current issue altogether. It just seems that most jurisdictions have no problem with the metal being connected to it, creating that potential parallel path. And to be honest with you, the only other way to do that would be to make sure that the neutral isn't bonded to the meter outside. And that's pretty much inherent to most of the residential type meters. So I don't know how you would do that without destroying the meter, right? So yeah, there are things. That's just one example of where you could have an issue where you think you're doing more and you're not. You're creating parallel paths, you're creating other issues. We've come to where we as a code panel, we cannot define objectionable current because we know there are standard practices that people do. And it even came up during our meeting at the Code Panel 5 meeting about, well, isn't that objectionable current to have a metal raceway between the panel and the meter? And since everything is bonded like it's supposed to be, and then the reality was we came to the conclusion that 250-142 allows us to use the neutral on the supply side anyway. So we're going to let you get away with it. But what we won't let you do is create an intentional parallel path. So using the raceway, to me, could be construed as intentional. So change over and use PVC. Right? That type of scenario. But running a separate conductor through it to make a bond when it's already bonded out there, then that creates parallel paths from point A to point B. And that's where you can get into creating a hazard. If you're asking me, Paul, what would you do to eliminate the potential for ejectional current altogether, is use PVC or isolation, or use an isolation connector or something that can, over at the meter, would isolate it away. And so then you'd have to find some type of changeover transition that would change over from rigid or EMT over to PVC in order to break that connection. Still got to bond your raceway, so you still have to follow all those rules. But at the end of the day, that would be the only option that you could have, is break that connection so that you don't have those parallel paths. Look, grounding and bonding can be difficult. We do things improperly all the time and stuff still works. So all we can do is talk about the concepts of how to make it safe. We understand that we don't want to intentionally, why run an extra wire through there if it's going to create parallel paths and cause a problem. If the raceway is already there, it's already there. You chose to use a metal raceway, fine, right? But we don't want to intentionally go over and above, thinking that you're going above code, adding that conductor when you know that the meter is bonded to the neutral, your service equipment's bonded to the neutral through the main bonding jumper. You're just making it worse. And that's what we're trying to address the best we can. Okay. In a perfect world, isolated transition fitting from PVC to metal so that it's not connected. I'm sure they make them out there, but that's a perfect world. Okay, so we do the best that we can. But running a wire through the nipple is us physically going to that next step, and that creates additional parallel paths, and we want to try to eliminate them. Hopefully that explains that to you. All right. Where were we? So these are the bondings. This is load side. Okay, load side is I'm sure, Paul, we're going to talk about all kinds of things on our podcast, on the grounding, the bonding ground podcast. We're going to talk about all types of that. Thing's just getting started. So metal raceways, cable trays, cable armor, cable sheath, closures, frames, fittings, and other metal non-current carrying parts that are to serve as equipment grounding conductors with or without the use of a wire type supplementary equipment grounding conductor are required to be bonded if necessary to ensure electrical continuity and the capacity to conduct safely any fault current that is likely to be imposed on it. Okay? All right? Any non-conductive paint, enamel, and most of those, in commercial, most of the panels that I had or I dealt with, hey, there you go, Adam. They love the Trade Hog. That's awesome. Yeah, it's amazing. It's amazing, and it's getting better and better. For those that haven't tried it, Trade Hog is our sponsor. Give it a shot. You can try it for free over on tradehog.net. Give it a shout out. So most of the panels that I dealt with were not painted. They didn't have any enamel on it. They were just steel or aluminum or something like that, and or galvanized steel. And so we didn't have that issue, but a lot of the ones that have the baked on enamel, you have this non-conductive enamel that either a lock nut on the load side, is what we're talking about now, can either dig into it and cut down in through that, or you physically have to remove so that you have that metal to metal contact. Now we're talking load side, so standard lock nuts are fine. They're evaluated to make that connection if you install them correctly. And obviously all the wiring methods that are metal are going to be sufficient. But you do get a full list of what can qualify as an equipment grounding conductor in 250.118. Okay, so definitely check that out. And of course, we're going to dig into all that in upcoming coffee hours, because again, we do this Monday through Friday. I got to have topics to talk about, okay? And it ain't like everybody's just submitting topics all over the place. So, all right, now let's talk about some stuff. Now I'm going to show you really quickly in the code. That's exactly what I read to you, so nobody thinks I made it up. Okay, I get that a lot lately. Say Paul's is making this stuff up. Okay, so this is exactly what I read to you. The non-conductive paint enamel cover, all of this was verbatim. Okay, unless of course something is made, a fitting is designed that makes it the removal unnecessary. So it has serrations or the lock nuts that have the tooth that bite into it as you tighten it, that kind of cuts through that paint or cuts through that enamel. If that's the case, then it's fine. It's not like a normal lock nut, which is flat, that won't cut through that material. Okay, there is a difference. Different types of lock nuts as well. All right. Just wanted to make that clear. Okay. All right. Now let's talk about reducing washers real quick, because again, you heard me talk about that when we're talking about services, and the right way to do a reducing washer is, the oops washers, is that you have to take out all of the KOs, and then you get the proper type of reducing washer, And you really have to look at the listing of that reducing washer, and it'll give you those instructions. And there's always two. One goes on each side. I mean, it wouldn't make sense to have one. But these reducing washers are used where the KOs or knockout openings in an enclosure is larger than the raceway or cable fitting to be connected. Okay, knocked out too much. And we've all done it. You're knocking them out the knockouts, whether it's concentric or eccentric. Concentrically easier to get out than the eccentric in my experience. But at the end of the day, you accidentally knock out too big for the fitting that you're going to be using. Okay. And they're usually in a matching pair with one on the inside of the enclosure and one on the outside enclosure. Metal reducing washers are considered suitable for grounding for use in circuits over and under, I don't know if you knew this or not, over and under 250 volts and installed in accordance with NFPA 70. Okay, so they are fine reducing washers. Again, there's people out there that say, oh, you can't use those for over 250 volts. Yes, you can. Okay, I will always use this little caveat, maybe. I will always say, that's what happens when Paul tries to use big words. I will always say, make sure you check the listing of the product. Make sure you look, if you're going to use it for something, make sure you look at it and it meets exactly what your intended use is for it, rather than just grab it and do it. Just verify. It just takes a little extra time to do that. Contact the manufacturer. At Prismium Encore Wire, I get calls all the time and some of the basic stuff, but you're better off asking than you're just doing and praying for forgiveness, especially when it comes to electrical, that type of thing. Okay, so the manufacturers are willing to help you, but a lot of that stuff has the information on it. You can go look at the UL listing. I think you can review UL listings for free. If you want them, you got to pay. But there's ways to look at it, or you can reach out to somebody like me. I have access to all the UL documents. Okay, more than happy to look it up. It takes a little time for me because, again, I have so many people submit things. But again, more than happy to try to help you. Regardless of the type and installation method of the reducing washer, the integrity and capability of the fault return path must not be reduced. Okay, so basically, long and short, install it the right way. So here's what it looks like right here. Obviously, this is a piece of rigid or EMT. I would say this is probably rigid, even though this says threaded fittings or EMT. It can be used on either types of wiring method done, but I would say this one is a piece of rigid right here, okay? Threaded conduit. And it's being held on by 2 lock nuts, which is an acceptable practice. We're on the load side, right? And so you have these 2 lock nuts coming in. Here's your panel or cabinet. You'll notice that the reducing washer, that there are no concentric or eccentric KOs remaining. So unless the listing for that reducing washer states otherwise, typically for them, and part of their listing is that you would remove, oops, you messed up anyway, right? Oops, I messed up. So remove all of the rings, okay? And give yourself like a pure punched hole, and then that's why you would buy the right type of reducing washer for what you're dealing with. So yeah, I get it. It sucks. And some people may say, well, Paul, wait a minute. I needed a 1/2 inch KO and I accidentally knocked a 3/4 or a 1 inch. Are you telling me that if that was a 2 inch hole, I'm just throwing numbers, you're telling me that I got to remove all the way up to the 2 inch in order to do a reducing washer? Yes, I'm telling you that. With most manufacturers of their reducing washers, that's what they will tell you you have to do. But again, I can't speak for every manufacturer out there, so make sure you check. Okay, but typically you would remove all of the impairments that are there, all of the rings, in order to be able to use the reducing washer, that type of thing. Okay, typically what happens. Again, you don't want to, that's up to you. I'm not here to be your daddy. Okay, you do what you need to do, but at the end of the day, that's typically how they're done. All right, and so let's see here. I was going to see if I had any. Yeah, I don't have anything I was going to do about go UL. I didn't think about pulling up a UL standard for these things. So again, you have to look at it at your own leisure. All right, so now we're going to talk about 250.96 B, because A to me is pretty easy, right? You have to use proper fittings, proper connectors, connect it to the boxes, make it tight, maintain it, bond, connect all those non-current carrying metal parts together that could be imposed into the ground fault current path. Make sure you do it all up tight. Do everything you're supposed to. Set screws, tighten the set screws down, those type of things. Do everything you need to do to create that path, okay? If you're putting in a separate wire in a method that is listed for use as an equipment grounding conductor, even if you consider the conductor to be supplemental, it still needs to be properly sized based on the overcurrent device, and that's 250-122, okay? Just remember that. All right, so let's talk a little bit about isolated grounding circuits. Whether you've ever run any or not, this is very common to pieces of equipment that may need isolation. And there's a right way to do this. And the isolated ground can be different than the need to have the traditional equipment ground. So let's kind of look at this, and it says requirements. It says if installed, okay? So again, if you need an isolated ground circuit, it's usually for a piece of equipment, and it'll denote that you need it. It'll say if installed for the reduction of electromagnetic interference, okay, EMI, on a grounding circuit, okay, you're getting noise, you're getting interference, you got a piece of equipment that's maybe in a studio, and they're like, dude, we need to have an independent, isolated ground run, okay, in order to reduce that EMI onto the circuit, that noise, things like that. Okay, well, that's fine. If you choose to run one, okay, then it says that an equipment enclosure supplied by a branch circuit is permitted, okay, so this is the equipment enclosure, is permitted to be isolated from a raceway containing circuits supplying only that equipment, okay, by one or more listed non-metallic raceway fittings, okay, located at the point of the attachment of the raceway to the equipment enclosure. And I'm going to show you a picture of this, okay? But basically, you may have your raceway, and your raceway may be a metal raceway. It may be an equipment grounding conductor, right? It may qualify in 250-118. And then you're getting to this piece of equipment, right? And now you need the separation. Now, also remember, you probably, even though it's a metal raceway, you probably have an equipment grounding conductor running into it, wire type. Well, they're all connected together, right? The raceway is connected to the box. All goes back to the main panel where it's connected to where? It's connected to the grounding terminal bus. It's connected to the neutral. They're all connected together, even all of those equipment grounding conductors that go out all over the building, right? So they're all connected to the grounding system. Well, that raceway, as well as the conductors inside of it, if it's just a regular equipment grounding conductor, all are intimate together, right? All the way back to the source. Okay, so this is saying, you know what? If I'm going to run a clean, a lot of people call it that, clean, isolated ground circuit, it can run all the way from the source, all the way through boxes, all the way till it gets not bonding to any of the metal along the way. It runs all the way to the source, okay? All right, so that is what we're going to show you in a graphic, but also in isolating the equipment from the raceway, right? Then you could put a non-metallic fitting on the end, right? And that would separate it. And that's kind of what I was talking about earlier when you were trying to do between the meter and the service. If you have a transition fitting that's non-metallic, that is designed to break that connection, then it is one way to mitigate the potential for objectionable currents, those type of scenarios. Anyway, so it says the metal raceway must comply with the provisions of this article and must be supplemented by an internal insulated equipment grounding conductor installed in accordance with 250-146D to ground the equipment enclosure. Okay, so let's look at a graphic. Nothing better than looking at a graphic, right? Okay, so here's your service equipment, and this is a panel downstream, and then of course this gets downstream, and then we have another piece of equipment that is further downstream. So in this scenario right here, you see we have an equipment ground that's running. So here we got this remote distribution panel, we'll call it. And you see where this is isolated right here, okay? And the ground is isolated. We don't have any neutral shown here. We're just showing oh, there we go. There's a neutral right there. So they're isolated. There we go. So this is floating. I thought because I thought we maybe were focusing only on this. But anyway, there you go, right there. Y'all see it? So there's your neutral, and you see this green screw in there. That just signifies that this is a remote distribution panel. We have our isolation. Again, we're not violating 250.24b, or if you're in the older code, it's 250.24a5. Okay, so we're not having the improper case to neutral. But what you'll notice is that for this piece of equipment here, that here is the isolated equipment grounding conductor permitted. It's passing through the panel. It's not terminating anywhere. Going all the way down, all the way through, all the way down over to the equipment. Right? There you go. Right? Now, let's not forget, though, that we could have this could all be metal, right? And until it gets right down to here, or maybe it gets to right here, and maybe this is where the non-metallic fitting takes place, or something right around in here, right? So we have to remember that all of this still has to be bonded, and it is right here. It's bonded to this enclosure. This is bonded right here. So this is all bonded, okay? This is all good. It's only down here for this specific piece of equipment, in order to achieve it, that it has an isolation, that there is a separation here. So this, right, is not connected to this right here. So it's got its equipment ground. It's just cleaner. In other words, it goes all the way back to the source. It doesn't go through and connect all these other components that are all bonded together. It's going all the way back. It's still got to have the equipment ground, still got to clear an overcurrent protected device. It's just not integrated through and using the building's system of everything tied together. It's going all the way back to the source, okay? So use of an isolated equipment ground conductor does not relieve the requirement for grounding the raceway system, okay? This is all done through this connection right here. Okay, so this is all done. This was all metal, that type of thing. So you get me? Doesn't remove that. All right. So that type of thing. So this is just giving you ability to do this. Okay. All right. Now let's see here. Conditions for applicability of an isolated ground. Number one, the equipment is supplied by a branch circuit and not by a feeder or service. Okay. Oh, there you go. To have this isolated ground circuit, it's got to be a branch circuit. Okay, so check individual piece of equipment, right? It says the isolation applies to the raceway containing circuit supplying only that individual equipment. Okay, so again, as you can see in illustration, this is the only piece of equipment, right, that is supplying this. This is the only raceway that's circuits that are in it that are supplying this piece of equipment. Okay. And that isolation applies to the raceway containing circuits supplying only the individual equipment. And the isolation is permitted to be accomplished by one or more listed non-metallic raceway fittings located at the point of attachment of the raceway to the equipment enclosure. All right, and so going over and looking at the code, this is the one we're talking about right here. So basically, we just verbatim went through each little piece of here. So it's just reminding you that the metal raceway shall comply with this article. Means it's still got to be bonded, all those type of things. And again, all we have is an internal insulated equipment grounding conductor installed in accordance with 240.46D. Okay, which if you click it, I'll show you that is, for example, isolated ground receptacle. That's the application for that if you're dealing with an isolated ground receptacle. That as well. Okay. All right. So let's see if we get back to the lesson here. I don't know how many of you run isolated ground, but if you do, okay. Let's go on a little bit more. Another more applicability. It says the installation of the metal raceway is required to comply with provisions of Article 250. It should be important to note that if you were to run PVC all the way, right, from that, let's go back. Let me go back to this picture right here. If this was all PVC, right, then on the system, you still have to have an equipment grounding conductor, okay? So this is running all the way down, okay? So running off. I'm not sure what you mean, Doug. Parallel paths are not generated by having multiple equipment grounds, okay? And the only issue you have, you would have that every moment, except for the fact that downstream, your neutrals and grounds don't connect together, okay? They're separated. They're isolated, okay? That's a requirement, 250.24b. I cannot have an improper case to neutral downstream. It eliminates that issue, okay? All right, so there you go. So if this was all PVC, it doesn't remove the fact that I could have a piece of equipment that I would run all the way from the source, run a separate equipment ground, and it would be isolated, okay, for noise, EMI, or something like that. Let's see here. The raceway must be supplemented by an internal insulated equipment grounding conductor installed in accordance with 250.146D. So even though it's not a receptacle, it means that you have to install it in accordance with that. That just happens to be the rules for an isolated receptacle, but there are rules within it that you have to follow, okay? All right, let's see here. Let's see, Doug, is there more to your question that I'm not answering here? What would isolated ground not make a parallel path for neutral if you take it back to the single panel setup where the exterior panel is used? Well, y'all come up with some weird stuff that would. If it was an exterior, no, because that parallel path is from the panel typically to the meter for that case. So. I don't think it would create any parallel paths or anything running back, that type of thing. I mean, can you do something and screw it up to potentially do something like that? Yeah, but I think the parallel path thing that we're talking about in a panel is where you have the main bonding jumper in, you have the grounding conductor comes in, and then you're taking a conductor straight out. And so you're creating multiple neutral paths from the panel back, right? On the load side, you can't have any improper case to neutral applications, that type of thing. So I don't think it would be creating anything like that. So at least either that, or I'm not thinking what you're trying to achieve. And I don't know why you would do anything like that. If I had an exterior panel, that's still the panel. I would take it all the way back to the panel. And we don't typically call that, that wouldn't be an ejectable current thing because they all got to go back to a panel. So just because the panel's outside, the objectionable we were talking about is from the service panel out to the meter, that type of thing. Okay, that's what we were talking about there. Let's see here. Where are we at? So elaborate a little more, Doug, if I'm not covering what you're saying. But a lot of people use the term first means of disconnect. And it's really either an emergency disconnect or it's the service disconnect, which also serves as the emergency disconnect, that type of thing. But everything that runs back to it is just, you have to run all your neutrals back. You have to run all your equipment grounds back. So I don't know that would be equipment ground. Plus that's isolated. So it's only connecting to the isolated ground is only connecting to the metal enclosure of the equipment in that branch circuit. Right? And it goes all the way back to the source. But remember, it's not connected to the neutral anywhere downstream. So you're not going to create parallel paths. It's isolated. Okay? And remember, we don't connect anything to the neutral downstream of the service. That would be violation, again, of 250.24A5 or 250.24B, depending on which code cycle you're in. Hope that makes sense, Doug. Let me know if it doesn't. I'll try to elaborate even more. All right, so let's look at 250.97. Now, this is a situation where we're bonding over 250 volts to ground. So it's not line to line, okay? It is, and y'all know when the single phase setup, you don't have phase to phase. There's only one phase. It's the phase that you're tapping midpoint in order to create a split phase installation. So when we're testing leg 1 to leg 2 in a panel, we're not doing phase to phase, okay? Because a phase to phase would be like what we do in 3-phase, hence multiple phases, A to B, B to C, all these types. That is phasing, checking the different phases. It's a kind of a misnomer in a single phase application to say you're going from phase to phase. You might be checking each end of the winding, or you're checking it to the midpoint of the winding of one phase, okay? Or winding, whatever you want to say. But it's not really phase to phase, okay? But not that I care as far as an industry, however they want to say that. It doesn't bother me because I know what people are saying. But it's really not phase to phase. It could be leg to leg, a line to line, those type of things. But it is really not phase to phase when you're dealing with a single phase because there is only one phase, that type of thing. Now you're checking the polarities, or you're checking the potential over that winding, over that phase between one point and another point. Okay, that's what you're typically doing. All right, so anyway, requirements for circuits that are over 250 volts to ground, which would be a 120 240 volt. If you have a 240 volt system that is a delta system, then you can have a corner grounded delta. Still going to be, if it's a 240 volt corner grounded delta, that would be over 250 volts to ground. If you have a Y connected 12208, then that, if a grounded system, then you're going to have it. You're going to, that type of system is not going to be over 250 volts. Like I said, a delta corner grounded is 240. That is not going to be over 250 volts. Let's see what else. The 120 240 volt, none of that's going to be over 250 volts to ground. But a corner grounded delta 480. Well, that would be over 250 volts to ground if it's a corner grounded delta. What else? Any 277 480 volt system, okay? Then 277 is definitely over 250 volts to ground. So those type of systems, that is going to require us to do what? And this is going to take us to flashbacks to yesterday, because the easiest way to remember how to deal with bonding when it's over 250 volts to ground is to treat it like a service, with one exception. You cannot use the grounded conductor, what we've been talking about. That was 250.92b1, where the use of the grounded conductor to bond the parts, also referenced in 250.142. With the exception of that, then I can use any of the methods that we talked about yesterday and 250.92 B2, B3, B4 in order to achieve it even with this over 250 volts to ground. Okay? So what I want you to mentally remember about services is all that assured stuff that we needed to do. Now, when you deal about bonding for feeders and branch circuits, when they're not over 250 volts ground, which is probably what you use mostly every day, 120, 240, 120, 208, those type of things, your normal fittings that are listed for that wiring method, connected, everything done, standard lock nuts, everything's good, you're fine. It's all going to be bonded, set screw type connectors, fittings, all good, everything's fine. But now you're going to jump back into, oh, wait a minute. You went from services, your enhanced bonding, down to your normal stuff. Now we're going back up to this little extra assurance that you have to do. And that's because it's over 250 volts to ground. Remember, the big difference between the service and over 250 volts to ground is you can use the neutral when it comes to services. You cannot when it comes to over 250 volts to ground. If that's something that you can lock in your brain, just lock it in the brain. Okay, now, what does this apply to? As you can see here, this is very common to a 480Y 277 three-phase four-wire system. Obviously, 277 to ground is over 250 volts. Also, corner grounded deltas, that are 480. Okay, they're going to be over 250 volts to ground. Okay, so David. So that's the way to remember it. When it comes to services, you got to do a little something. When it comes to over 250 volts to ground, okay, not between legs, to ground. Then you got to do a little something, something. That's the best way to remember it, okay? And the reason I say it like that is because I have a lot of people when it comes to exams, the working clearances, 3 feet, 3.5 feet working clearances in 110.26. So many people get that wrong because the way they read it, it is to ground, okay? So it's not from leg to leg, okay? It's to ground, right? So, or if it was 3-phase, it's not phase to phase, it's to ground. So when you see something about working clearance and it's a 122 40 volt panel, it's about the 120 because that's the part that's to ground, okay? So again, so important, the little nuances, because I had a lot of people that will read something and see a certain voltage and say, oh, 600 volts, it's a 600 volt system, I have this certain clearance, and they don't read the details. It's to ground. So the same way that this, it is over 250 to ground, not leg to leg, line to line, it is to ground, okay? All right, eliminate shock hazards from equipment energized by the downstream fault. Again, it's also going to have certain equipment that is already rated for their eccentric knockouts, for example, on some boxes are already rated for over 250 volt applications. It should be able to easily find that on the box or the literature when you're buying the box, okay? Not all panel and cabinets are rated that way. The typical concentric KOs are typically not rated for over 250 volts to ground, okay? But when you punch your own holes, it doesn't matter. So typically in commercial and industrial, we're punching our own holes anyway, so it's not going to matter. But in a lot of the residential enclosures, obviously people say, well, can I use a residential panel with a cabinet in a commercial application? I know it says residential, but the electrons don't care. Well, you may be able to get away with that depending on the voltage and what you're doing with it and what the voltage to ground may make it so that that piece of equipment is not adequate for you to be able to do that. Okay, important things that you always have to look at and just not go blindly into it. That type of scenario. Okay. All right, so let's go look at the general rule for 250.97 first, and then we'll look at all the exceptions. If you don't encounter any of these quote impairments, okay, you got some allowances here. All right, so let's go look at the code quickly. So here we go. So this is 250.97. Okay. Notice it says it had bonding for over 250 volts, and it didn't have to ground on there, but it was in the actual language. But again, this is sometimes things that we do as code panel members, right? Is we look for things for consistency, right? And like, you know what? If it talks about it down here, it probably should say it in the title. So people say, why do you change the code every couple of years? I don't know, because we miss things, right? So there you go. So for circuits over 250 volts to ground, the electrical continuity of metal raceways and cables with metal sheathing that contain any conductors other than service. Okay, so remember, we're not doing services. We've already done that. That was yesterday. Okay, other than services. So that's feeders, branch circuit applications. It says, shall be insured by one or more of the methods specified for services. 250.92B1 except for B1, which if you remember, if I go back and show you, B1 is talking about right here, connecting to the grounded conductor. That is not in play. But all of these other methods, perfectly fine, okay? A threaded coupling or threaded connector, which may come with the standard lock nut with it. It means that if it is listed for grounding and bonding and it is applicable to services and it's been evaluated for that, then it's evaluated as a complete system and it's okay. Again, always check the manufacturer of the fitting if you're going to be using it on a service to make sure, because again, there's a camp out there that say, no, you can't use that fitting because it comes with a lock nut. And the code says you can't use a standard lock nut. Okay, I happen to know that I talk to people from NEMA on these panels that say, no, if I buy a fitting and it is okay to be used for service, which again is a little above the norm, you don't just say that, yes, all of them are. It's kind of like with Myers hubs, you have to check. if it is listed for grounding and bonding, in a conjunction of its listing, it will include the fitting and the locking device. Everything will be together. Then you use it as you purchase it. Okay. So again, there'll be the caveats where people say, no, you can never use a standard lock nut. And there'll be others that say, yeah, I have no problem with the lock nut in conjunction with the fitting, and they have been evaluated and they're for use for service, which is a little higher bonding requirement than it would be downstream on the feeder side. Or in this case right here, where it needs to be a little bit more robust for an over 250 volt to ground application. This should tell you, folks, you really have to look at the listing. You really have to look at your equipment and take some time next time. Look at it. If you're going to do a service and you're doing threadless connectors on threadless couplings on a raceway that's going to contain service conductors, for example, take some time and look at that fitting, right? And see what makes it different that it may. And also remember, that only works if you have no KOs, okay? It only works if you have no KOs, because remember what we said yesterday? If you have KOs, you're going to have a bonding jumper regardless, okay? Make sense? Okay. Just want to make sure that we cover all that. All right, so let's kind of go back to the code real quick. So here it says, okay, so you're going to follow all those methods. So we don't have to reinvent the wheel. We can go back and use any of those that we talked about yesterday. That's your homework. Go back and watch yesterday. Now, here's the exception. If, you see that's in kind of grayed out, it's kind of got a tan on it. Okay, so this was saying if you encounter them. If you have oversized, concentric, or eccentric, or eccentric, however you want to say it, knockouts, and they're not encountered. Okay, so if you don't encounter any of these, okay, good. Either you punched it yourself, okay, right, or they've all been knocked out, okay, gotcha. It says, or if a box or enclosure with concentric or eccentric or eccentric knockouts is listed to provide a reliable bonding connection, the following methods shall be permitted, okay? So if you don't have any KOs, you have no impairments, or the box or enclosure is already listed for use in this case, an over 250 volts to ground application. And I'm going to tell you, by my experience, not 100% of the time, but from my experience, most all of the boxes, now I have people telling me that it's on all metal boxes now. I am not going to say that for gospel, even though I believe they say it in link. We'll go look real quick. I know that the boxes that I've encountered that do say they're used with over 200 volts to ground typically are the eccentric or eccentric boxes. Means they have the knockout and then they have the rings that kind of protrude out from it, right? Not the round ones. I'm not going to say that in all cases. You need to check your cabinet. You need to check your boxes. You're the one doing the install. You need to make sure. Don't say because Paul says. You need to validate that. If you know more than I do about the boxes and you've looked up the listings, okay, that's up to you. I'm just saying. As y'all say, I'm a hack. I don't do work in the field anymore. So, you know, I got my haters on all platforms that say people like me just teach because we can't do anymore. So, okay, I'll embrace that if that's how you feel. All right, so here I can use threadless couplings and connectors for cables with metal sheathing. I can use 2 lock nuts on rigid metal conduit, intermediate conduit. You saw that kind of a sandwich effect. Okay, one on the inside, one on the outside of boxes and cabinets. Okay, again, I'm not encountering any of this. Or the boxes has KOs that are already listed for this over 250 volts to ground. So then I could use this, okay? I also could do this method anyway if I'd have just a knockout and I want to use rigid. That's very common in commercial applications. Put a lock nut on the outside, lock nut on the inside. It's perfectly fine. Here it says I can use a fitting with the shoulders that seat tightly against the box or cabinet, such as with EMT. You know, I got that kind of a little lip on it. It sits against it, that type of thing. And it says with 1 lock nut on the inside of the box or cabinet. That's perfectly fine. And then there are other listed fittings that you might find out there. This is a catch-all. because people like Bridgeport, Appleton, and all those are always coming up with nifty little things. And so again, if it gets evaluated for grounding and bonding and it's okay, then you can do that. Now look in here, and this is talking about the guide real quick. So we'll see what we get educated here based on NFPA. And since they seem like they're pulling it straight from the UL guide, we probably can take it for what it's worth. It says, bonding around pre-punched concentric or eccentric or eccentric knockouts is not required if the enclosure contains the lock nuts is listed as suitable for bonding. Okay, that's what we were just talking about. All right, now it says the UL guide information indicates that concentric and eccentric or eccentric knockouts in all metal outlet boxes evaluated in accordance with UL 514.A. That is the metallic outlet boxes. Again, that looks like it only applies to metallic outlet boxes. It says are suitable for bonding without the use of additional bonding equipment, such as bonding type lock nuts or bonding bushings. The guide information further indicates that metal outlet boxes, okay, so only metal outlet boxes, may be marked to indicate this condition of use. All right, and I'm going to tell you that most of the manufacturers that spend the extra money to make sure that this is evaluated, that their eccentric or concentric knockouts are beefed up, they're probably going to put it in their literature somewhere. Okay, either it's going to be on the box, it's going to be on their promotional literature or something to let you know, that type of scenario. Okay, so now I can also tell you from being in the trade, I can most certainly tell on a like 11/16 box, when I go to knock out those knockouts and they're eccentric or eccentric, they don't want to come out. They have extra welding on them. They are extra connections. You got to beat those things. Whereas the concentric ones on a panel come out very easy. You can push them in with your finger, in the most part. So usually you can tell on a box or device box or something that is just a bit more. I've seen them on 11/16 boxes. They just are, a lot of the 4-inch square boxes, they just are so much more robust that you can tell. But always check with the manufacturer, but just know that they do make boxes out there that are already evaluated under UL 514A that say, you know what, you don't need to do anything else. They're fine. Leave those KOs in there. You're fine. All right. All right, let's see here. What else do we got here? Okay, so these are the exceptions. These are all the things we just covered right there. Right. So let's look at this example here. So this is an overturn at 50 volts to ground. Let's kind of analyze it here because we don't know what all's going on. Okay, we don't know what all things are happening right here. Okay. So 250.97 requirements, exceptions have become the rule for most of these installations. A few installations of over 250 volt branch circuits are made with service type bonding. Means you're following all of the rules as you would in a service. Okay, let's see here. So here, I don't know if you can see. You can't really see the knockout. I can zoom in. So so this is more like this eccentric ones right here, right? So all this just is saying that standard eccentric knockouts not permitted without a bonding, bushing, or jumper. Okay, if this box was not listed for that, let's assume this box isn't. Okay, because of this statement, this is just a reminder that you need to check with the manufacturer. Not every box is created equal. Okay, they might even say it in the box. I don't know. All right, so down over here, so this one right here's the raceway coming in. This is an EMT. Okay, this is a tubing coming in, set screw type fitting. It's coming in right here. So this is EMT. So it says cable. So this is a cable. Maybe the FMC coming in. This is a cable right here. This looks like might be like see, it's got a green in there. So this is MC cable coming in right here. Right. It says so cable, EMT, and FMC fittings with outside shoulders. Okay, so they're outside little ledge that rests against the box. Okay, and a lock nut on the inside. Okay, is perfectly acceptable for this application. Okay, and I don't know These actually look like all of the KOs have been removed, but I don't know that. So again, just a good collection of the, oops, all right, hold on. Just a good collection. And what we're using right here and right here and right here is right here. Fittings with shoulders that seat tightly against the box or cabinet, such as for EMT, flexible metal conduit, and cable like an MC, and one lock nut on the inside, okay? Again, this only takes place if the oversized, concentric, or eccentric, or eccentric, however you want to say it, are not encountered, or unless the box itself is listed for use with an over 250 volts to ground application. Makes sense? Okay, and so this is just showing you that this would not be, if this box wasn't listed for that, right, then this would not be because of the KOs. The only caveat to this would be to remove all of the KOs, right? And then you're not encountering any KOs. And if you're not encountering any KOs, then you can use the fitting. And the shoulder would mount against the metal, and you could use this lock nut on the inside. You see how that works? So this is just an overall picture that allows us to kind of put all those little pieces together, okay? All right, so tomorrow, by the way, we're going to be getting into 250-102. We're going to be talking about sizing the supply side bonding jumpers. We're going to be talking about bonding jumpers in general, the attachments that have to take place. We're going to show you how to size it if you have a single raceway, if you have multiple raceways. We're going to talk about how to size the supply side bonding jumper in accordance to 250-102. And of course, we're going to be touching on the equipment bonding jumper, which is 250-102D as well. And all of that will be covered in tomorrow's episode. All right. So hopefully you got something out of the day, a little tidbit in the conversation. If not, I'm sorry. There's other channels, but if you enjoyed it, I appreciate you coming. Let's go on and do some giveaways real quick, get some people on the list here and do some spinning. So let's go on and put people on this list. And I know a few things that are going out to folks that did not have to be engraved is going out today. Darlene says probably some today. So look for that. Douglas Webb. Douglas, you got a free wire waffle. So if you want that wire waffle, again, this helps eliminate the issue with 312.5C, bringing in all of those cables through one TA or one connector, which is a violation of the code because you're required to secure each cable to the actual enclosure. This solves that problem. If you're interested in getting your free wire waffles, send us an email at support, SUPPORT, at fasttracksystem.com. Let us know your mailing address and we will get that out to you, Doug. All right, let's spin the wheel again. Thank you, Adam. Yeah, I put plenty of years in the field. But there's always those people, right? The young bucks, the ones that go, just because they go out and they feel like they work really hard every day, and they do. There's no doubt this is a hard trade, but they seem to forget that they're going to get old too, and it just is what it is. Do I care? Do I want to go back out in the field and work for a living? No, I don't. I couldn't do it today. I couldn't do that. Depot says, play to get rid of the concentric eccentric knockouts of you. Yeah. One of the things that somebody said, why don't manufacturers just get rid of the damn knockouts and just let everybody can purchase their own hole punch set, punch your own holes and everything. Okay. The commercial guys are like, dude, don't we always do that? Right. Industrial guys are like, next. In the residential, we get used to those knockouts and things like that. All right, we got you down, you sold for the conductor link card. Good luck to you. Hopefully you'll get in the drawing here, and you will win on June 30th. Let's go. doorman. We'll just say Alex, and you get in the drawing for Trade Hog. 12-month subscription to the basic plan, which we still have to set that up. We didn't add this until this drawing cycle, but we have it. It's a month-to-month program, and we have to set up a 12-month one because we gave one away, but we have to give an offering so people can purchase it annually instead of having to have it come out. I hate the monthly thing. So a lot of people said, look, let me purchase it for 1 year and be done with it. And that's what we do over on Fast Tracks Tube. So I don't know why we started that way, the month-to-month thing. I don't know. But we'll get it all squared away, and you'll see an offering to be able to choose it to just do it annually if you want. And so we're working on that. Hopefully this week that'll be completed. And then we'll get you taken care of, Rob. I need another piece of paper. Another wire waffle. Felix, for those that do want the wire waffle, again, that win, I do have a select group of those. They're in single individuals. They're hard to come by, right? Okay. Single individuals. Send me, Felix, send me an email, support, SUPPORT, at fasttracksystem.com. You can also do it through paulabernathy.com if it's easier to remember. There's a portal you can fill out your information. These actually are listed, and it solves a need. And I like products that solve a need, that type of thing. All right, let's see here. Paul says, should the NEC change RT50 to read bonding and grounding rather than grounding and bonding, since bonding is the first thing you need to do? Well, no, I think that it doesn't matter, but I think grounding is the first thing you need to do. So when you're breaking ground, you have to establish a grounding electrode system. So you're grounding first. I mean, you're putting in your electrodes, or maybe they're inherent to the construction of the property. Maybe you have a UFR ground or whatever. So that's really the first. So that doesn't really work out that logically. I think it's fine how they call it. It would be semantics to change it. But if you're thinking about it as it comes out of the earth, right, then grounding is actually the first thing you actually try to establish, that connection, that reference to earth. And then everything else just kind of comes together, that type of thing. Okay. Does that logic make sense to you? All right. Also, when you're running a circuit, remember, Paul, we're actually running first, right? So we're running that out to facilitate the operation of an overcurrent protected device. By virtue of running that and establishing that connection to earth for voltage stabilization through the system, it's also serving a bonding function. So there has been quite a few people that said, why don't we just call it equipment bonding conductor? Well, because then we'd have to put the note that says it also does a grounding and it stabilized voltage. So why mess with it? You know what I'm saying? That's why we put an informational note under equipment grounding conductor to say that it also performs a bonding function, that type of thing. We have to be careful, because I think that we could mess with that so much that we end up screwing something up. And we're, again, code panels, if you haven't heard, you can screw things up. And I'll talk about something here real quickly in a second, because it was a tongue-in-cheek thing. Titan Electric. Okay, you got the VD card. Okay, all right, you got the drawing for the VD card. Congratulations to that. Let me talk about one thing real quick. I had done a video on when it came to the code change about not requiring the receptacle outlet at a peninsula or island. And I gave Code Making Panel a hard time. And I knew what I was doing, and I don't think they're bringing anything up in the NITMAM. In the 2026 edition of this, since you still have to have the provisions there, people were misinterpreting it, the fact that if you happen to have a room divider or if it was a wall, that you still had to meet the wall spacing. But the way the code was written, you could not have any receptacle below the counter. And so the fact of the matter is you could have a receptacle below the counter if it needs to meet the wall space requirement. It obviously wasn't within 12 inches. It wasn't going to serve the countertop. But you might be meeting a 210.52a wall space requirement. Well, in the 2026, they revised the language a little bit to say, you know what? If it's a required receptacle or a permitted receptacle outlet that you're installing on an island or peninsula, we're going to let you do it. Say the permitted one or the required one may be because it may constitute wall space, depending on the design of the system or design of the counter or however it's being done. It's going to let you put one down low. At least it's going to codify it. Let's put it that way, because I think we're going to do it anyway. But it's going to let you put one down low as long as it's not within 24 inches of the countertop. And so they're going to let you do that. Now, the one that I was kind of teasing them on was the issue about the drawer. I was teasing them in order to hopefully get a nitmam, somebody to change something. And I looked it up last night. I was looking and nobody submitted anything. So when it says in the drawer, I think that they're given an allowance now to be a receptacle to be below the countertop. Okay. That could necessarily be within 12 inches of the counter. But they're going to let something be below the countertop if it's in a drawer. Now, I was using the concept of playing devil's advocate and saying, and I realized that I might be misleading people, so I wanted to make sure I'm clear. It's not talking about putting it in the face, although the discussion on the code panel was about ADA and being able to get to it and all this kind of other stuff, which is how I wanted to bring up the issue where somebody could read this as putting it in the drawer. Not in the drawer, but in the drawer. So in the face. And I could see how that could be interpreted. And I was basically doing a tongue-in-cheek to let people know that that may be an argument that you can get into with your AHJ if your customer wants one below the counter, and you know the code says you can't, unless it's more than 24 inches from the top surface, which is what they're putting into the code, if everything goes right. There may be an argument for you to say, well, I can put one in the drawer. And they're going to say, well, we meant for it to be in the drawer. And I think that's what Ryan Jackson and them meant, in the drawer, like at a workstation and things like that. But if you read it as it's written, somebody could argue when you say in the drawer that it is mounted in the front surface of the drawer below the countertop. And they could argue this with an AHJ. And it kind of defeats the purpose of them not wanting to have receptacles below the countertop. So I don't think in their mind they want it in the face. But the way it's written, I can see an argument. People say, well, that's a stupid argument, Paul. Nobody would ever win that argument. If you go on TikTok, Instagram, and you realize that there are obviously electricians and AHJs and people out there reading this stuff, somebody's going to say that it means in the drawer. And if they go back and look at the history, they're going to see where a reference was made to ADA and the requirements in ADA, and that's all about height, the restrictions. And you're going to see where somebody's going to say they wanted it in the face of the drawer because of ADA and height restrictions and all this kind of other stuff. I'm just saying it's a mess. I think they literally mean in the drawer itself, ones that are built into the drawer for like workstations. And those would be, obviously could be within 12 inches. They're in the drawer below the countertop. I think that was their intent. But the way you read it, I can see us arguing, oh, you want one on your island? Well, the code says you can't. But Mr. Inspector, it says that I can put it in the drawer. Then you got to discuss whether or not they mean in the drawer. And you're like, what would it do any good in the drawer? I mean, they can't get, what's the point? They could pull the drawer open and then some kid could hit their face on it when they go by. Oh, here we go, safety again. I'm being facetious here, but I can see the argument. So that needs to be cleaned up a little bit. It's obviously not going to happen this code cycle, I don't believe. I don't think there's a knitman for that. But anyway, maybe I'm just being too flippant in how I'm reading that, because I really think they just mean in the drawer, not in the drawer, like the drawer face. Type of thing. Anyway, all right, folks, that's it for today. Hopefully you got something out of today's lesson. I appreciate all of you. Thanks for joining me. Tomorrow we'll get into supply side bonding. We'll 250.102. We'll talk about all that, sizing, all that good stuff. Tomorrow, we'll talk about those various bonding jumpers and really kind of get deeper as we go here on this journey in bonding and cover it in tomorrow's episode. All right, folks. Until next time, stay safe. God bless, and we'll catch you on an upcoming episode of Coffee Hour. Peace.